Okay. Yeah, I'm recording it and this presentation, and so it will be available for you in our own our website later. Okay, let's go through the UCD 400 device. So this is the scheme or the connections for the UCD 400. It is connected to the PC, the controlling PC, through a USB interface connected here. You have a power input. We provide a separate brick power supply. It's connected here, and there's a power on-off switch here. There are two DisplayPort connectors side by side on this edge. The other one is input, means that the functionality as an sync, DisplayPort sync or analyzer can be used with this interface, and this interface is a DisplayPort output. So it then UCD 400 acts as a pattern generator or a DisplayPort source. Both the sync and source functionality can be operated simultaneously. So you can, for instance, verify the operation with the loop map mode. So connected the input and output together, then you can see both sides of the operation. On the right-hand side edge of the UCD 400, you have various connections. Two of those connections are used today. There's an Ethernet connection and a programmer mini USB connector. They are needed for the firmware update or UCD 400. The firmware update procedure is a fairly complicated task, and it is explained in detail in the manual. And I believe that we will have a training separately dealing with the firmware update. Firmware update is needed whenever there will be a new major release of the software. So both the software in the PC, in the host PC, and in the UCD, and the firmware in the UCD 400 will change. Okay. UCD 400 operates as such when delivered without any additional licenses. But for instance, the compliance tests and some other advanced features are enabled with separately provided licenses. In the appendix of the user manual, there's a table listing all the features, UCD 400 features, and listing to which license group they belong. Most of the functions, basic functions, are available by default, and then some of the features are enabled only with licenses. And there's a license manager in the release package, and by using this license manager, you can enter the licenses. The licenses are stored in the PC, the controlling PC, and you can install the licenses in any amount of PCs. So you can have licenses in many PCs for the same device, but the licenses are tied to one particular UCD 400 hardware. So the licenses are entered by, if you get an, normally we send an email with the licenses, and you can just copy and paste the character code. There's a list of characters, and you can just copy and paste the characters in this by clicking here and pasting the characters here. And when you ask for the license, you will need the device seed number, because device seed number tells us which device in detail you are asking for the licenses for. And once the licenses are entered to the PC, they will appear here in the license manager list. Okay, then we go to the UCD console itself. The controls and functionalities in UCD console are divided in tabs to make it easier for the user to visually see the related controls. So on the left-hand side vertical tabs, you can select role DPRX, DisplayPort sync or analyzer. DPTX is a DisplayPort transmitter or a pattern generator. And then event log is a separate tab where both the sync and so functions can be accessed. We will see it in a later slide. The horizontal tabs, they are the function of the device. We will go the tabs one by one in this presentation, and I will go in details, show you the details of each tabs. And as mentioned, the UCD 400 can be simultaneously be a sync, a transmitter, and a receiver. And this is handy, for instance, if you want to test a repeater device. So you can both see what is coming into the repeater and what is what the repeater is sending out. And all the tabs, they can be detached. So you can, by right-clicking on this tab, you can click and there's text detach, and then you can have this tab separately. So for instance, when working with the repeater, you can have the two operations side by side in your screen. Okay, let's first concentrate on the analyzer function. So when UCD 400 is a DisplayPort sync. The first tab is the video tab. Then UCD 400 acts as a frame grabber. You can enable the preview or the captured video in this tab, and you can take snapshots of the stream by clicking here, and when you click it, the captured one frame is shown on a separate tab. I think I have it. And then you can save the snap on the from the snapshot screen or directly from here. Please note that if the source is sending HTTP encrypted video, it's HTTP protected content, then UCD 400 doesn't allow you to store any captured frames, any captured material. You can preview it, but not store. On the lower panel of the console, you can see the resolution, the video mode that you are capturing. In this case, it has been Full HD 60 Hz, RGB color mode, and 8 bits per color. And this is a count for the captured frames. In case the source is not sending RGB color mode, then you can select which color mode you are previewing. Because Windows is using also always RGB color mode. If the source is sending YCBCR, then if you select automatic, then UCD console automatically converts it to RGB. But you can also preview it in some other color mode. No, for instance, if you put no conversion, you will see exactly the pixels as they are received by UCD 400. In case the source is sending multi-stream video, so several channels, it is indicated here with MST, multi-streaming. And with this selection, you can select which virtual channel you are monitoring. Okay. Okay, you can record both the individual frames or series of frames. And if you're recording a series of frames, you can either store them in the buffered mode, and this means that UCD 400 captures as many frames as can be fit into the internal frame buffer, and only that after that stores the frames. Then you can have every frame consecutive, all the consecutive frames from the moment you start. The other one is a non-buffered mode where the UCD 400 records the frames real time. But since the USB connections between UCD 400 and the host PC is not fast enough, UCD 400 cannot record all the frames captured, or the console cannot store all the frames that are captured by UCD 400. That naturally depends on the video mode. In small resolutions, this might be possible, but in larger video modes, there will be many frames skipped. In some cases, you want to record real time, and in some cases, you want to record all the consecutive frames. And if you want to record the consecutive frames, it's buffered mode, and non-buffered mode is real time. All this is also explained in the user manual. The second tab is audio preview screen. In the same way, you can disable and enable the preview, and then you can play the captured audio back in your PC. And if you select the default audio playback mode, then it will play it according to the selection in your PC. Yeah, in this case, the UCD 400 has been captured to, so it's eight channel audio, and all the channels are visualized here. And in many cases, the source is sending 8-channel video, but only left and right main channels are actually contain video. So it might be that you have all 8 channels here, but then only 2 channels have this graph or indication that there's some content. And again, on the lower panel shows the mode that the source is sending. In this case, 8-channel and 4400 44.1 kilohertz and 16 bits audio. You can also record audio. By clicking this, there will be a pop-up menu where you can select how many seconds you want to store, and it's stored in the audio file in the PC. The next tab is a link tab, which is I think the most used tab in this when evaluating a source device, because here you can see the status of the link, how many lanes are used, what is the status of the link, if all for each lane, if all green LED lamps are lit, that means that the link training has been successful. And then 600 means the voltage swing selected between during the link training, and the pre-emphasis value selected in the link training. And this is for all CAD channels. If in case there are only 2 channels used, these 6 LED lamps will be lit, and these will remain gray. The link status panel also indicates, okay, lane count, how many lanes are used, MST mode, the status of the MST mode, enabled or disabled, FEC, it's error. It was we talked. It was a forward error correction, ADCP, and scrambling, and which bitrate is selected, and then some other, for instance, is the DSC, display stream compression, is it enabled or disabled? Link configuration. Okay, we in DPRX mode, the UCD 400 is a sync device. The sync device cannot control how many lanes will be used, but you can simulate the capabilities of the UCD 400, even though UCD 400 is capable of using all 4 lanes and the highest bit rate. Then you can simulate a situation where, let's say that only 2 lanes are available and it can only support 5.4, so the high bit rate. And then also other capabilities, simulate the capabilities that the UCD 400 has. Does it support multi-streaming and this TP3, 3P4 capability, forward error correction, and does it support DSC? And all these capabilities, they are enabled only after you click the apply. The value you select will not be effective before you click apply. And then normally you have this checkbox checked, so the UCD 400 will create an HPD, so indicate or simulate a new connection, so that the source knows that something has changed in the configuration. On the top panel, you can control the hot plug detect, the HPD line. These indicate the status. This led if the cable is connected, if the sync detects that a cable is connected, and this is the status of the HPD signal. Normally, it's up or asserted. The term assert means up, so logical high. But you can manually deassert and assert it, or you can give a HPD pulse. Means that the source, we are a sync, the source notify a source that a new connection is anyway occurred, and you can control the length of the HPD pulse. I mentioned in the first training that the only way for the sync device to communicate with the source is to alert it that something is wrong by giving a short pulse on 1 millisecond pulse. A short pulse, so indicate that the source will read the registers in the sync status, and if something is wrong, then do the corrective actions. The lowest panel indicates or indicates the status of the signal or the streams that are received. In this case, multi-streaming is used, so the source, or we are receiving 4 individual streams, 4 individual video from the source, and we UCD 400 emulates, in this case, 4 syncs, so it can receive all the 4 streams. And this is the details of each of the received streams. In case there will be a single stream, so if we disable the multi-stream capability, or okay, actually, if we have the multi-stream capability, the source can still decide to send as many streams as it needs, only 1 stream or multiple streams. Then we would, in case of single stream, we would have only details of one stream here. The next tab is the EDID or EDID editor. Means that the EDID is a memory in the sink that indicates its capabilities for the source. One of the first things when a source and sink is connected, the source reads this EDID. The EDID memory or UCD400 is programmable. So if you have an EDID, if you copy the EDID from some other TV or monitor to a file in a certain format, then you can load the EDID to the EDID editor and write it to the hardware. So program it to the EDID memory or UCD400. In this case, the source would believe that the TV or monitor where the EDID was copied from is connected to it. So you can emulate many devices with one UCD400 device. Actually, this is a very much used feature in the in testing or the DisplayPort source software or drivers. So you connect by using UCD400 as a simulation device. You can simulate tens or hundreds or different type of monitor, the capabilities or different types of monitors, and monitor how the source device, the software in the source device is handling the chains. Does it detect the capabilities of the emulated device or simulated device correctly? Okay, and when you click here, you have, do we have a, yes, this is the EDID editor where you can actually edit the content of the EDID. This needs a bit more detailed capabilities, the knowledge how the EDID should be constructed. But this is a way where you can create, or where the customer can create test cases to be used in this EDID emulation. For instance, the screen that I'm showing is it shows that the content or so the first or so-called 18-byte data box, and this is the default timing or the device. So in this case, the default timing or this sync where the EDID belongs to is the 3840 by 2160, means the 4K device. There are many registers here, many capabilities, and changing these capabilities, you can change the way that the source should react when connected to this device. Okay, the next step is a DPCD, DisplayPort Configuration Data Register, or the sync. there are two capabilities that a sync device, a monitor or a TV has. One, the support device has. One is the EDID that tells about the which kind of content, so which kind of video and audio the monitor is capable of receiving or previewing and playing, while the DPCD registers, they tell about the capabilities of the DisplayPort interface. So the technical capabilities of the interface, how many lanes it supports, what bit rates it supports, etc., etc., etc. And in the first training, I listed that there are many there's many address spaces reserved for certain capabilities, and with this tool you can evaluate these capabilities and see capabilities and statuses. Some of the registers tell about the capability, and some it tells that what is the status, what is, for instance, the quality of the image or the stream it's getting, the sync is receiving. And using the aux channel, the source reads these capability values. So reads the contents of this memory when it wants to see the sync status, or writes to a register to indicate the sync. The source indicates to the sync what to do. So this is the communication register between the source and the sync. Okay. Next tab is an HACCP, so content protection. UCD 400 is compatible both with HACCP 1.3 and HACCP actually 2.3. The latest HACCP was upgraded recently from 2.2 to 2.3. Actually, in terms of UCD 400 functionality, the changes were minor. So we are also compatible with 2.3, but it is a bit older screen capture. The console still indicates HACCP 2.2. With this checkbox, the user can simulate, indicate, does it want that the UCD 400 is capable, HACCP capable or not, so that the connected source will react accordingly, and the user can monitor what happens in each case. The security keys for HACCP, it can be either the normal keys that the actual devices will use. So each device, each TV, each monitor, each a player has an individual HACCP key, and when the device is manufactured, the key is programmed to the device. But there are certain, for production testing, for instance, or testing, you can use so-called facsimile or test keys, and in this case you can select which kind of keys will be used. UCD 400 device has its own HACCP keys pre-programmed. Okay, and from here you can see the status of the HTTP handshake, where if the sync and when then the authenticated light is lit, then it means that the sync and source have done the basic HTTP handshake. So in a way that both are ready for the HTTP receiving or and sending the HTTP protected content. And when the actual content is received, this topmost green LED light is lit. So in case in the upper case, currently UCD 400 declares itself as HTTP capable, but the source, since the source is using HTTP 2.3 or 2.2, it is not authenticated on HTTP 1.3. So one of the HTTP methods can be used at one time, not simultaneous, both simultaneously. Okay, this is a screen where you can monitor so-called secondary data packets that the source device sends. They are so-called metadata, so with which the source indicates the sync about the details of the contents that it's sending. So it's a help for the sync device to interpret the content in the right way. Let's not go into details. Okay, forward error correction. There's a special training that goes very deep into technical details. I don't go to the details of that. I mean, forward error correction means that if there are only a few few errors in the stream, then with this FEC method, the sync can correct these errors, individual bit errors from the screen. And let's not go into further details. Okay. The source duty testing tab lists the built-in tests that the user can do with the UCD 400. By default, so-called simple link training test is enabled, with which you can do the basic, test all the link training with all the different lane configurations and the link rates, and then some video and audio tests based on the CRC, cyclic redundancy check. So checksum, based on a checksum or the bit content or the frame. So the UCD 400 hardware calculates the checksum or all the color bits or the captured frames, and by comparing the checksum in a reference or checking or comparing the checksum or consecutive frames, it can check if there are any bit errors sent. So The user can, for instance, say that capture 2000 frames and with a stable video, test video, and see if the receiving is stable. Okay, the other tests that we show here, they are enabled only with licenses. In this case, we have the link layer, this report 1.4a link layer tests, and all the HCP tests that can be enabled for a sync device. So all the possible licenses are in this case have been enabled. Okay, when you run the test, you click on the lines, the test you want to run. You configure the so-called test parameters. Okay, this is example of the test parameters needed for the link layer test. This is very sophisticated, and you really need to know what you are doing when you are filling these this table. But this is actually what is requested by the link layer compliance test standard. All the capabilities that are listed here are actually defined by the standards, because the tests will use these capabilities when it decides which severity and which kind of details functions will be used in the tests. Let's go back to the screen. Okay, once you have configured or provided the capabilities or the source device that you are going to test, and you select the tests that you want to run, you defined how many times you repeat the test, and if you and then you define the delay between the tests, then you click the run selected. Then UTD 400 automatically goes through the steps or the compliance test, or the test anyway, even these tests, through the steps of the test, and in the test log here you will see the result or the procedure or the test. I mean, what the test device, so 400 UC 400 is doing, and how the DUT, the device under test, replies. And once you have run the test, okay, and in the end of each test, there's a statement, pass or fail, and actually this you can see the pass or fail status also in this matrix. How many times the test was run? Was it skipped because all the capabilities that you provided here, did it pass or fail? And if you repeat the test many times, you can see if every time it passes or it sometimes fails. There's a certain rules set by the standard organizations. If you have a failure, then you have to repeat the test in so many times, and then it needs to pass in all of those tests. Okay, once you have done a test sequence or test runs, you can save the test runs in reports that can be shared with colleagues. They are in HTML, so read by a web browser. and I don't remember if I don't have an example or the report in this presentation, but again, the report are explained in the user manual. Okay. Then we jump to the source functionality. In the same way, when the source or pattern generator functionality is selected, you have again a set of tabs, horizontal tabs here, where you can select the capability that you are going to control. The first one is the control of the pattern generator. Again, in this screen capture, multi-streaming is selected. So we have the capability of sending multiple video streams in the same DisplayPort connection. Here you can select one of the predefined video modes. There are many predefined video modes. You can find the list of predefined video modes in the appendix or the user manual. If you want to modify the timing, so see if the DUT, so in this case, a DUT is a sync via our source. If the sync is capable of receiving a bit of the spec signal, you can click here and then modify the settings or the timing with these registers. Or you can, by clicking here, you can open a separate timing editor. Yes, this is the timing editor where you can create new timings in the list, your custom timings in the list, or actually if since the list or the standard timing is very long, it's sometimes very tricky to show in the standard timing list only the timings that you will be using. So I mean, reduce it to the reduced amount of timing shown, and you can do it by disabling the timing or unclicking in the from the checkboxes here on the left hand side of the panel. So only the timings are checked in this list are shown in the dialog here when you click here. That there will be a drop down list of the timings and you can select from there. Okay. This is for timings, and then you can select which color depth you are using. 6, 8, 10, 12, 16 bits per color is supported. Then you can select which pattern you're using. Do I have a list of that? No. Again, in the appendix of the user manual, there's a list of the standard video patterns included in UCD 400. But you can also upload your custom video pattern by clicking here. You click here, then there is a dialog where you can select the bitmap file and upload it here and use it as a test pattern. By default, there's an this a bit pattern that looks like this. I don't have exact the enlarged screen here, but it includes the hairlines for all the fixed timings in the pattern, so you can check that the sync is receiving or positions the captured video correctly. Okay, and what is very important, whatever changes you do here is they are not applied automatically, or so the pattern is not changed automatically unless you click the apply button here in the right hand lower corner, or if you have checked this box, then the software decides if the, for instance, the register values that you are giving here are sensible. I mean, if they make sense. If they are not in a way good, then they are not applied. But once they are good, they are applied automatically. Okay, from here you can enable and disable the displaced read compression, and I have a couple of special slides for that later in this presentation. Okay, this was the timing editor. Okay. In the same way, you have audio generator. You can either select one or the standard waveforms. We have sinus, we have triangle and square, and you can define the signal frequency and other details. Or you can load load an audio file, VFE file, and play it, and then you can start the playing the audio here and stop it here. Okay, this is again the link page, showing that in the same way as in the source size. First of all, the result of the link training, how many lanes are trained, and the success, and then also the capabilities that are enabled in this in the source device. And again, you can because source is a boss of the connection, the source can decide how many lanes are used, or what how many lanes are used and what bitrate is used. So you can say that, okay, let's do a link training with only 2 lanes and the high bit rate, and click here and do the link training. But please note that if you selected in a pattern generator multiple streams, for instance, at high resolutions, they might not fit to the link configuration that you enable here. So then the UCD400 is sending garbage. And it's because this is a very powerful tool, then UCD400 lets you send garbage. So you have to be very careful that you set the link capabilities in a level that are able to carry the patterns that you specified here in a pattern generator tab. Okay, and in testing, for instance, the chips, it's important to send some special patterns. And from this dialog, you can select, are you sending the active video, so real video and audio, or are you sending some special bit patterns that are not actually video at all. Idle pattern means that the links are there, but nothing is sent. And these are the link training, the patterns used for link training. You can test them. For instance, if you are developing your chip hardware, you can enable them here. PRBS 7 is a very commonly used pattern. For instance, the physical layer measurement, etc., etc. Okay, this is a panel where you can control the voltage swing and the pre-emphasis used in the link. You can by default it shows the result of the link training, the how the sync and source determined in the handshake during the link training, but you can override them. But please note that the sync and source, they are actively monitoring the capability of the link. If you set some foolish values here so that the link will fail, the sync and source will automatically correct them. So even though you put something here, you will only here see what actually will be used, what values will be used. Okay. This remember I talked about the on the testing. You can use the CRC, the checksum, or the color bits, or the percent frame for checking the stability of the frame. Also here you can see the calculated the CRC that the sync or the source calculates for the frame. So see, in this case, you can see that these are the exact values that you are sending, and then in the sync device, if you are able to see the calculated values in the sync, you can verify that the sync receives the pattern in a correct way. Okay, in the same way, HTTP, the authentication status, but again, since the source, we are now source transmitter, then we are the boss. We are deciding when to authenticate and when enable encryption. So when when the content sent in the stream is content protected. Again, the FEC, the forward error correction, you can test the FEC function by simulating, putting some, generating some errors, and see how the DUT, the device under test, reacts. Let's not go in details. Okay, I don't have the sync DUT testing, the last tab, screen capture of that, because it's exactly similar to that we saw on the when talking about the receiver or the sync in case of source testing. Okay, let's see the event log. Event log has two portions. Event log that records all the events in the stream, and second part is the aux analyzer that only analyzes the aux channel content, so the handshake between the sync and source. Let's concentrate on the aux analyzer. which is actually was it introduced now in this latest version, or maybe it was earlier, but it's pretty new in UCD 400. You remember that Unigraph has a separate device called DPA 400, which is only a DP aux channel monitor. And the capabilities or the aux analyzer in UCD 400 are about the same as in DPA 400 aux analyzer device. Okay, here you can see the list of transactions. So each line represents something happening in the line. And the from column, you can see that the source requests read one prides, and the sync replies, source, sync, etc., etc. And you can see the what's happened, and then by clicking one line, you can see the details or the measures, past details of the message here. As I mentioned in the first training, understanding the aux channel communications is considered to be the key, or understanding the whole interface. So it's very important to monitor this in case there are problems, for instance, in the compliance tests, or one of our customers says he has problems with the UCD 400 device in communicating with their DUT, then almost the first thing we are asking is please record the aux channel communication and email it to us. So from the communication, we can see, in most cases, we can see where the problem is, or at least focus on the details of the problem. Okay, in this case, in the case of UCD 400, we have actually two aux channel monitors. One which analyzes the communication in the input port, so as a role or sync device or receiver's device, and the other one is from the output port. It analyzes the aux channel in the role of a source device, a transmitter device. You start the capture here, stop here, and then again you can save it as a binary file, or you can save it as a report, HTML report. So to be sent to colleagues or stored and later evaluated with the web browser. Okay, this goes a bit details, and we are actually used also 1 hour, so I will not go this in details, and actually it could be an item for another training, but I'm sure that the DSC feature will be one of the key features that your customer will be asking. So this is important thing to understand. But I already sent you a link to this presentation. It is in the Unigraph web server. It can be downloaded from there, and we can have a separate session for DSC if needed. Will that be okay?
Yeah, I think that's okay. Yeah.
Okay, good. So any questions so far? This is the end of the material I was planning to show you today.
From here, from my side, I would have